Hello and welcome to Workholding 101, where it's our goal to help you be more successful in your workholding practices by just sharing information, tips, things that we've learned over the years that might help you be more successful on your manufacturing floor. Today we're going to talk about milling pockets in vise jaws, or basically cutting pockets in soft jaws. And we're going to go through some things that we go through here in our production facility that hopefully might help you be more successful on your floor. So we have a production facility here, and so what you're seeing is an example of multiple pockets cut into a jaw set. Generally to grip, in this case, a round saw cut billet in the first orientation, and then machine the part complete in the second orientation. So how do we grip a round part in our jaw pockets? How do we cut these pockets out for both orientations? What are the things we need to be thinking about when we do this? This particular fixture will hold 8 orientation A parts and 8 orientation B parts for a total of 16 parts under the spindle on each load. So the part that we're looking at fixturing up today is this part here. We call it a peanut because it's got a profile that looks a lot like a peanut shape. It's actually called a flange. It's got a boss on it, a couple of bored holes in it, and this is the part that we're going to process. So it's generally made in 2 orientations. So we're going to need to cut pockets for our orientation A, which is the raw billet, where we're going to come in and cut our profile out and bore some holes, and then we're going to flip the part over for our orientation B and make the part complete. So once you have an idea of how you're going to process the part, in this case we're going to do 2 orientations, the next thing that you got to figure out is your material size. So we need to go through and figure out how to do that based on the part itself. So in looking at the print, when you add everything up, the part has an overall length of 1 inch 970. So we're going to go with a standard 2-inch size stock. To have about 30 thousandths worth of material to clean up, or about 15 thousandths per side. In some cases, based on how your stock size varies, you may want to give yourself around 60 thousandths of extra stock to have 30 thousandths aside for cleanup. In this case, our stock's pretty consistent, so we feel pretty comfortable going with the 2-inch size stock. So the next thing that you want to think about once you pick your material size is your pocket depth. Or how much material do we want to hold on to. And in most cases, it's a pretty good idea to start with around 200 thousandths worth of material to hold on to. That's usually adequate to cut at the feeds and the speeds that you'd like to be cutting at. So as a general rule of thumb, 200 thou is what you want to be gripping on. So when you start gripping on less than 200 thousandths, you can run into some problems with your cutting forces exceeding the gripping power of whatever work holding system you're using, and at that point you're getting into toe clamping applications and have to be real careful about your machine feeds and speeds, or the cutting forces can rip the part right out of the jaws, and that's not a very safe situation. So just one other thought about the amount of material that you want to hold on to. Obviously, if you want to hold on to more material to cut more aggressively, that's safer, but it also comes at a cost, because the more material you're gripping, the longer your billet size saw cut is. So you're going to end up using more material. And in a production milling environment, you want to kind of optimize your billet length so that you can cut as aggressively as you want, but use the least amount of material possible. So with most vise systems, you have 2 sets of jaws, a fixed jaw and a movable jaw. The general idea is to cut a profiled pocket into the jaws, so when the clamping is activated, you squeeze the part with enough force to obviously hold it during the cutting operation. Vices come in many different shapes and sizes and have been around in the manufacturing environment for a long time, but the principle works the same on all of them. The movable jaw gets pushed against the part, and then the part gets trapped or nested against the fixed side so that the part is held with enough power to handle the cutting forces that are being applied. So traditionally, most vise systems are open and closed by hand or by manually cranking a handle. And this is fine in most job shop environments or if you've got a low production run. But if you get into production milling, the time it takes to manually open and close a vise system by hand can really hinder your productivity and efficiency. So the vise system we're using in this lesson is something called a multivise. It's a system of 16 densely populated 2-inch vices that are activated using a wedge clamp. The wedge clamps are pulled down using a socket head cap screw, and they push a movable jaw in 2 opposite directions with equal force and can generate up to 3,500 pounds of holding power per jaw. These types of systems can be useful in production milling environments for a couple of reasons. So one of the first reasons that these type of systems can be useful in a production milling environment is these clamps are low profile clamps. They allow you to get more part density under your spindle and take advantage of something that we call multiple part work holding. And there are many benefits to this idea of multiple part work holding that we're going to get into in an upcoming video and discuss it in more detail. Second reason that these type of systems are really useful in a production milling environment is that the clamping can be automated. With the flip of a switch, in this case we're using hydraulics, in literally 2 seconds you can clamp and unclamp 16 parts in this multivise system. The clamping and unclamping, when you do it manually, takes a lot more time. So the loading and unloading sequence takes a lot more time, and you lose efficiency. You have spindle downtime, which is generally not good for a production milling environment. So let's get into the steps that you need to go through to mill the pockets. Most manufacturing engineers or machinists, once you have the material size picked, will then pull up a CAD model of whatever jaw set they're using and draw the pocket profiles into the jaw sets on both the fixed and movable side of the vise system. And the CAD program will typically create the machine code needed to cut the pockets based on the information that you feed into it for the tools you're using to cut the pockets. So once you have the program written to cut the pockets, you're going to probably put it on a jump drive or something like that, take it out to your machine. You're going to load the code into the machine, the CNC machine, and you're going to obviously have the vise system located on your table, and you're going to begin to prep the vise system, create 0 points, get your shim set out, and so we're going to get into the purpose of the shims when you're machining pockets into vise jaws. So you're going to need a shim set to put in between the fixed and movable jaw. The shim sets that we use are about 1/16 of an inch or 62 thousandths thick, and they work pretty well for us. But you put the shims in, you're going to want to tighten your vise system down or clamp, and then machine the pockets. And the shims are an important piece of the process because if you machine the vise jaws without using the shims, you could run into a lot of trouble with your holding force or your gripping power when you actually clamp your vise system. In other words, when your vise system closes, if you machine the pockets without the shim set, the travel in your jaws will actually bottom out at the same time you start gripping the part, which is not going to create much holding force, and it's highly likely you'll rip the part right out of the jaws, and that could create a dangerous situation. So by using the 60 thou shim set, what that allows your vise jaws to do is it gives you that 60 thousandths worth of travel once the jaws engage the part to hold on to the part properly so that you don't have an issue with the part being ripped out of the pocket. So let's move on and discuss a couple tips that'll help you in your work holding practices, make your processes more effective. One of the first things that we want to talk about is something we call the 75-25 rule. It has to do with the position of your pockets in the movable and fixed jaws. What we mean by this is you're going to want to machine your jaws in such a manner as to have 75% of the part seated on the fixed jaw or the non-movable side. This allows a little more rigidity and the ability to locate the part properly, and it also helps with keeping the part flat and provides more of a base for tapping the part down. So another work holding concept that we want to discuss is this idea of 2-point, 3-point, 4-point contact when you're gripping a part. In this particular example, we're talking about holding on to a 2-inch round billet, and it's pretty common to cut your pocket diameter maybe 5 thousandths bigger than the actual diameter of your material so that the part will fit in and out of the pocket for ease of loading and unloading. So what happens when you clamp the part is the jaws come together and engage the part using 2 points of contact. Depending on how aggressively you're cutting, this can be okay, but what we've found is that gripping on 3 points of contact when holding a round part gives substantially more holding power. So here's how we go about doing that. If you cut just a little relief into the back of the pocket on the fixed jaw, what that will do is it causes 3 points of contact to hold the billet when the clamp engages. So generally, more points of contact will give you more holding power. You can also cut relief into the pocket on the movable jaw in a similar manner and actually create 4 points of clamping. That may be overkill depending on your application, but it does help in some situations based on what you're trying to do. Another idea that might be helpful to you is to put an undercut in the bottom of your jaw pocket, especially on the A orientation where in many cases you're using a saw cut billet. The reason this is helpful is many times a saw will leave an edge burr. Burrs can often cause location issues in the fixturing and even cause misloads if the burr is big enough. So the undercut helps eliminate the jaw from mashing into the burr in the corners of your pocket, and it just helps keep the part flat and allows the jaws to engage the side of the part cleanly, more or less minimizing the opportunity for the burr to affect the process negatively. So the same idea is going to hold true if you're trying to hold a rectangular part in your jaw pockets, only you're going to want to put the relief in the corners of the pockets, all 4 corners. If you cut some relief into the corners, any burrs on your billet will be minimized or become much less of an issue, and again create more process stability on your floor, and a more stable process keeps the machine running and makes your QC department happy. So just a couple more quick things before we end our video here. Up on our website, if you go to the clamp section of the site, you can get information on all of our clamps by going to the specific clamp that you're looking for, and there is CAD data up there that you can download and pull into your CAD system to overlay onto your fixture plates when machining the jaws. We also have a clamp pocket size chart, and that's there. We recommend putting the clamps in a pocket on your fixture plate so they don't rotate at all. We also have a safe cut chart up there which tells you how far into a clamp you can cut before you'd really do any damage to it. And then we also have our spring locators up on the site. Those are useful in fixture design to help locate your parts properly against the datums and make it easier for your operators to load and unload. That's it for now. Thank you for watching, and until next time, good luck.